Okay, this is the second task for the homework assignment related to lesson 6. So we've just finished, let's go back and look. We just finished all the calculations to get the extended sales and the extended cost of goods sold based on monthly data for 2019 for the roasting side of the house. And one of the things that we did that was kind of unique is look at what the weighted average price is and the weighted average quantities here. And we need those because we based all our previous calculations. When we did the last assignment, we were looking at per unit cost and per unit price. We calculated an average for that. So it's especially important when we're looking at total cost, because when we calculated this particular value, this total cost, we based it on a weighted average of the number of units that were sold. And because we have different prices, it actually makes a difference. If these prices were the same, we wouldn't have to worry about this. But they're not the same. The volumes aren't the same, right? And the prices aren't the same. And so the weighted average price here is based on that difference between the quantities and between the price. So we have to do both. We have to take a weighted average price and weighted average quantities to get our answer. And because our costs here were based on weighted averages, we have to base these values down here based on the weighted quantities. Okay, so moving forward, I brought those across. That's your weighted average price, and that's your weighted average quantities that came from the previous page. So they're brought forward, and this rolls out for you the income statements for each of the various months. Okay, so look at the profit in December. It's quite low, and that's because we take that time off. We don't have any sales that we're booking in that period. But the grand total is the same as what you looked at in the last assignment, 43,057, 43,057. So what we're going to do here in this slide is we're going to graph each one of these accounts, sales account, the cost of goods sold account, and these various expense accounts, so that we can see how they behave over time, and we can calculate any fixed components that are involved there as well as any variable components. And I'll talk more about that as we move through these various graphs, but it's extremely relevant today as you're thinking about small businesses. As you can imagine, this company, this coffee company, is having to shut down right now. So they're probably letting their employees go, and they're not making any coffee. They're not working. They're not doing anything. But they still incur certain costs. So they still have a certain level of utility costs that they're going to incur. They still have to pay for insurance on the building. They still have to pay for property taxes and other types of things that are incurred as just being in business, right? Whether they sell anything or not. And so we'd consider those fixed costs that need to be covered, and they're going to have to make those payments to stay alive. And the rest of these costs that they can get rid of, so they don't need to buy any green beans, they don't need to hire all these people, they don't need to pay for cleaning up the cafe every day because there's nobody in there. There's a lot of costs that are discretionary that they can remove or get rid of temporarily as we get through this crisis. Anyway, we'll talk more about what that looks like when we graph these. So what I've done for you, let's go back. What I've done for you is I've created right here a table that has the various months of the year in it, and I brought in the weighted units that you see up above that we had from the previous slide. And then I dropped in the sales value, starting with January. So that came from here, and this one came from here, and this one came from here, right? So they're all linked. They're all referenced down. So I just created it in this format, and I'll show you why. Because you can highlight that, just like that, go to Insert, hit Scatter Graph, and create a graph of that data. Let's pull that down. And we can make it a little bigger. And I'm going to label it. This is sales. Try that again. Well, goodness. Sales. And I'm going to give it some color. So it kind of pops off the page a little bit. Looks better. All right. So what you see here on the y-axis is the dollar amount of sales. So that's this. This is y-axis. And then this is x-axis, which is the weighted units are on the x-axis. So what you're getting is the amount of dollars that are generated, this is sales, generated for every unit that we sell. Now, if you right click on any dot, doesn't matter which one, can be any of them, and then hit add trend line, this pops up over here, and you should display the equation on the chart and display it in R-square value. Take that, click on it, pull it up so you can read it a little better. And let's study what that's telling us. So y equals mx plus b, right? It's the formula for a straight line. And it's telling us r squared is 1, which means that it's a perfectly linear line. It's perfectly positively correlated as well. Okay, so the correlation coefficient is also 1. What you're seeing here is all of the dots, so all of these pairs, let me explain that a little bit. Each dot is a pair. So that's one dot. That's another dot. That's a third dot, a fourth dot. So there's 12 dots there. They're kind of crunched, but there is 12 dots there. Notice they all fall on the line. Now, if some of these dots were out here or down here and fell off the line, it would still give us the best fitting line, because that's what linear regression does. It gives us the best fitting line to all the points that we have. It's just your r squared would be less than 1 if the dots were falling off the line, which means that essentially not all of those dots are in a tight relationship. It minimizes the distance between the dots, but it doesn't give you a perfect estimate of the future. And that's kind of what we're doing here, is we're looking at, well, how reliable is this formula? And r squared is telling you that by a value of 1, it's extremely reliable because all the dots are following that line. Okay, they're all ants in a row. No one's straying off into the wilderness. Okay, so if you get dots that are not on that line, then you'd say, well, this line isn't a perfect predictor for me of the future, because sometimes we fall off that line and things go in different directions for whatever reason. So that's what r squared is kind of telling you, is the strength of that line in being a good predictor of the future. And this line is a really strong predictor. Everything's lining right up. Okay. So what that's telling you is the slope is 12.32. Remember, that's your average price. That makes sense. Every time you sell 1 unit, you get $12.32 in your pocket. And that's one weighted average unit for this business. One weighted average unit. Okay. And then this thing on the tail end there, that scientific notation, essentially what that's telling you is that the intercept is 0. Right, that's 2e to -9, which means you're 9 decimals in, and it's 0. So the fixed intercept is the origin, right? So it's telling you that if you drew that line all the way down, you would hit right there. In other words, if you don't sell anything, so this is quantity sold right here. If you don't sell anything, you don't make anything. So that's where we are right now, right? They're shut down, they're not selling anything. Maybe they have some online sales, right? But anyways, if they don't sell anything, then they don't get any revenue, right? So sales are 0 if they're not selling anything. So what you do then, let me start this one from scratch. So here we go. So you've got to get the high-low method. So I want you to do it both ways. And you might be asking me, well, if it's a straight linear line, why do I need to do it both ways? And if linear regression is superior, why do I need it both ways? And the answer is sometimes the high-low method is handy because you maybe don't have a computer and you want to ballpark it, right? So you want to you're in a meeting and you want to real quick kind of ballpark what a trend might look like. And so this is a really cool way to do that. So what we do is we find the low point, which is the min in the data set. So use equals min, highlight that, and then hit enter, and it pulls in whatever the smallest one is. And then here we're looking for the high point, so that's max, highlight it. And I already highlighted them in green previously because I wanted that to stand out on your template. That's the points right there that you're going to be using to calculate the high-low method. And so one of the things that sometimes students get tripped up on is, okay, for the low point, I grab the lowest dollar amount here because the rise is the dollar amounts, the sales. We just did the run. Whereas in this case, they match up. So the lowest dollar amount is that one. So there's no problem, but I want to make sure you realize that you can't pick any other value anyway, even if there was one that was lower than this, right? So if you had a point, let's say, that was down here, like that, which is possible, right? If you ran some kind of promotion and you discounted your price. So if you had a dollar value that was lower than this dollar value right here, then you don't jump ship and go to a different value. You got to stay, because this is a point, and you're looking to grab a point on the graph. So a point is a pair. So you got to grab those. So that belongs with this one, and this one belongs with the high. So the slope is going to be the difference between these two, the rise, over the difference between these two. So you go equals. Divide. All right, no surprise, because it's perfectly linear, you're going to get the same answer. So the slope is 12.323, which is the price, the average price. Now to get the fixed cost, remember your formula. Fixed cost is a component of total costs. And the formula I gave you was that total cost equals fixed costs plus variable costs. Well, you know what total cost is. That's one of those points. So you can use either the rise, either the high or the low. Doesn't matter. I usually use the high just out of habit. So take that total cost. You know what the variable cost is going to be, so back that out. So you take that, this, times quantity. So that's the slope, right? Times x, the quantity. Back that out, and that's your fixed cost, which is nothing, right? For one thing, this is sales, and if you don't sell anything, you don't make any money, the intercept is zero, right? You start right there. If you don't sell anything, you don't make anything in terms of revenue. So that makes complete sense. So it really should, I say fixed cost there, but really it's intercept, right? Intercept is what we would call it. We're looking at revenue here too, so it doesn't really make sense to say fixed cost. But for the rest of the ones that we're going to do, cost of goods sold and all these other expenses, then it is a cost that we're looking at. And it's also the intercept. Okay, it's just how the model works and what it tells us. Okay, so if you want to, you can fix that and just call it intercept. It's not really fixed cost there because we're dealing with sales. The rest of them are fine. Okay, so let's do the cost of goods sold. Same thing. Look, it's the same quantity that you had up here in the pink row, but now we're going to be focused on the cost of goods sold here. Okay, cost of goods sold right there. So I brought those down for you. So they just referenced down, and I did that so you could real quick make your graph. So insert, scatter chart. Go ahead and do it. Pull it over. Resize if you want to. You do not have to. And click on one dot, add trend line, click display equation. Okay, so here we go. Let's rename it, color it up a little bit so it looks a little more interesting. You can pick whatever color you like. Okay, all right, so let's look at our equation here. This is our linear regression. So we use a scatter plot, we put on the line. Notice every point's on the line. So r squared is 1 again. Nothing fell off the line. They're all on the line. So this is a very predictive equation. If you notice what you have for an equation for cost of goods sold, you'll notice that fixed cost, there's your intercept right there. So that's what fixed costs are going to be. And that makes sense because back here, that's exactly what you had, right? That's exactly what you had. And the variable cost was computed by taking the sum of these times the weighted quantity. And if you add them up, let's do it right here, equals this plus this plus this. These were the three variable ones. What do you know? You get 779. So it's no surprise to me when I see this equation, that's exactly what it should be, right? And because everything is on the lines perfectly linear, then that lines up is perfectly. It's based on a weighted average of the quantities and a weighted average price. All right. So that's saying the intercept hits somewhere down here around 5,000. It would cross The y-axis right about there, so it's telling you you've got these committed costs. And you think about it, in this environment, if you have to shut down your operations, which I'm sure they're closed, you have to shut down. You don't need to buy any raw beans. You don't need any people roasting beans. If you're shut down completely, assume not. I mean, perhaps they have some online orders that could go in and fill, but they're all non-essential businesses in some of the states are supposed to be completely shut down. So just go with that so you can understand how we're trying to get down to that kind of information. Like, what are my rock bottom costs that I would incur if I didn't have any production going at all? So that would be things like depreciation, insurance, property taxes. So costs that I would incur, even if I weren't there. Costs that I would not incur would be things like the green beans. I don't need them. I don't need people roasting beans because I'm not selling any beans. I don't need the bags. I don't need the labels, right? So those are the kind of costs that you'd consider to be somewhat discretionary, that you could let all those people go and just stop buying stuff, right? So that's kind of the thinking here, is try to split those costs out. What costs are committed and what costs are variable, in a sense that they vary with production. All right, so if I do using the high-low method, I'll tell you right up front, we're going to get the same answers as we got here. And the reason why is because this is r squared equals 1, perfectly linear. Every point, even the high point and the low point, are on that line. So we're going to get the same answers. But I just want to show that to you and prove it to you. So the high was this, and the low is this. So the quantities are going to always be the same no matter which graph we're creating. We're basing it on the quantities. Notice that they're all the same. They're all the same. Okay. And the dollar amounts are what are different. So the dollar amount here is this, and the dollar amount here is this. And so the slope is the rise over the run, which equals the difference between this divided by the difference between this. Okay, pardon me. There we go. Okay, and you can shorten that up. All right, so there's your 779, your slope, same number. To get the fixed cost, take the high total, so total cost, and back out the variable cost, and that'll give you the fixed cost, because the total cost curve is fixed plus variable. There it is right there. So I'm taking y, which is this number, and I'm going to subtract this, the variable cost. And so I'll get this fixed cost. So that's the slope times this. And that's exactly right. Okay, let's do another one. I'll move faster now. Insert, scatter, put it down, resize it a little bit, look better. Okay, so that's nice, a little more spread out for us. These are payroll expenses. Let's add a trend line. And okay, they're all right on that line. So there is a fixed component every month for my payroll, and there's a variable component. Okay, this is an expense, so I'm going to color it up the same as the other one. Okay, so this is variable. It's about costing me about 6 cents a unit in variable labor. So that's mostly either part-time labor or people who are involved in the production process, right? So actually that's not right. So we've already pulled that up here. The production labor is up here. So this is mostly your SG&A expenses, because we're looking at the roasting business. So it's any of perhaps people who are working on the web page, or people who are working to help with the customers and the sales part of the business. So these are the variable components, and this is the fixed components. So we're paying some salary and some wages, is basically what that's saying. All right, let's do it. So this is the low again, and the high. It's always going to be these 2 points. The only difference is grabbing these dollar amounts. And if you get, actually, you know what? We can just do this. Copy, paste. Okay, and you did get the exact same thing. Okay, so the formulas we used here are the same formulas we would use here. In fact, that's going to be the case for all of these, right? So you could technically, if you want to save yourself some effort, just paste. And you got it. You're good to go. All you're going to do is your graph. Okay, so let's highlight this. Insert, scatter, scatter. Okay. You want to color it up so it stands off the page a little bit. Right mouse click, add trend line, display R squared, display equation. Okay, so this one, notice that the intercept is 0, right? And you got that down here too. So it's strictly variable. What it means here is that you incur $1.28 in, this is promotion and selling costs for every 1 unit that you sell. Right? Okay. So we've got that already copied. Let's do it. Let's do them all. Paste. Whoops. Try that again. Copy. Paste. 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 All right, all we got left to do is scatter diagrams. Well, let's grab the right thing. Okay, there's a slight fixed component there, so the intercept would actually hit it for 54, 55 bucks. And then you have a slight variable cost per unit. And this is utilities. So essentially their fixed costs on the utilities are around 55 bucks a month, and the rest of it varies. So it makes sense you're paying more for every kilowatt hour that you incur, and probably as sales go up, you're incurring greater power expense. You're using more, you're using the roaster more. Okay. This one's going to be straight across. Watch this. Okay. Let's get that over here. That is a fixed dollar amount. You're seeing that there's no slope in that line whatsoever. And if you look at the high-low method down here, the slope is 0, and the fixed cost is approximately this 15. So these are all truncated, but if you push them out, you'll see that's exactly what they are. 14, 5, 37. They're rounding to 15 there. Okay, so that's what you got on that one. Let's clean it up. Okay, we can try to do the trend line on this. Sometimes I find it doesn't work, at least on my Mac. When I use my Windows-based machine, it works just fine. I just give you that heads up. Sometimes Excel on a Mac, and I'm not using a Mac right now, is not perfect. There's little quirky things like that. But let's give it a try and see what happens. If it creates some weird looking data like that, so it drops the line way down here and it converts this y-axis to 15 all the way across. That's not what I want to happen. So I'm just going to undo it. I know my high-low data is perfectly fine like this. Right, so I know that that is exactly this number because it's a perfectly linear setup. Straight line means it's fixed costs, right? So no matter what volume I'm at, I'm still going to pay 15 bucks a month for my waste removal. Okay, let's do another one. This is repairs and maintenance. Okay, there's a slope on that. Add the trend line. display the equation in the R squared. And that matches up with what we got down here. So it's costing me about $14.18 every month on average, plus about 0.003 cents for every unit that I sell for repairs and maintenance. So there seems to be a variable component to that. So I do more if I have more money, basically. Okay, let's do this one. Okay, it's fixed, $30.28. You can fix up the title. If you want to do the trend line, you can. If you're on a Windows, if you're on a Mac, it might not work for that fixed line. Oops. Another fixed one. Change title. Another fixed one. Almost done. This one's 100% variable as well. The intercept is 0. Whoops, sorry. Try that again. There we go. Let's change title. This one's fixed. One more. Depreciation expense. There we go. All right, so again, that one is fixed. I'm not going to do the trend lines. Like I said, on a Mac, it does weird things, but this is going to be fine because that's perfect straight line, right? Straight amount. So to get to the next step, we're going to be in good shape. So this is the end of task 2, creating those graphs and computing the high-low method. Pretty easy going once you get started with it. So good luck with that. If you need any extra help, let me know, but you should be able to figure it all out. If you need to watch the video a couple of times, that'll probably do it. So I'll pick up again in the next video for task number 3.